All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue working on the sliding window mechanism that I'm, working on. The idea is that we want to, so we have transcripts, which are, hold on, I can show it here. Actually, can I show it here? Do I still have the thing? Um, I can't remember where it was. Here. So we have timestamps similar to this. This is just a little example. Did I say we have timestamps? We have transcripts, and the transcripts um, have timestamps along with the text that is being said during that timestamp. So this way we kind of get subtitles that, okay, from this time to this time, this sentence is being said, from that time to that time, that sentence is being said, and so on. My understanding is that um, okay, never mind. I take that back. I was about to say that my understanding is that it does it per sentence, but no, I'm seeing an example right here that it actually breaks up longer sentences into uh, multiple chunks. So the idea here is that we want to create a sliding window, conceptual window, where each window consists of how many ever chunks make up 60 seconds or less, around 60 seconds. I mean, if you look at the start time here, you'll notice pairs of seconds. These are the numbers here are seconds. If you look at the first value in each pair, that's the start timestamp, and the second is the end timestamp. So this is basically telling you that if we're looking at the first chunk, then this is telling you actually, if I select it, it might be better. Yeah. So if you look at this, you look at the 0 and 4.2, 0.0 and 4.2, this is saying that from 0 seconds to 4.2 seconds, we have, okay, we are live being said. And then in the next line, we have from 4.2 seconds to 5.2 seconds, it says, what's up, guys? And then it goes on like that. So what I want to do is I want to create a 60-second window, and how many ever dialogues, how many ever of these chunks fit within 60 seconds, I want to put that many chunks in a window and just store the chunk. And then we're going to slide 30 seconds down. So if the initial chunk is from 0 to 60 seconds, the next chunk is supposed to start from 30 seconds, going up to 90 seconds. Then the next chunk goes from 60 seconds to, it's 1 minute, right? 60 seconds to 120 seconds, and so on. So this is how basically we are creating 60-second windows, and we are sliding in 30-second increments. Now, pandas and NumPy and all, they do have sliding window functionalities, but none of them are similar to what I'm looking for. A lot of them tend to be more index based, and the windowing mechanism usually expects a fixed length of windows, window, windows, window, usually expects a window of fixed length. And in my case, it's not going to be a fixed length window because the number of chunks within a window can differ. It's not always going to be the same number of chunks. There can be any number of dialogues that have been said within 60 seconds. Okay. That's one thing that I need to work on. And then after that comes the NLP section, which is I'm excited for that because that's going to be one of the first times that I'm actually using NLP. I know almost nothing about NLP. I've touched NLP in the past where I've done like when I was learning to use the Transformers library, the Hugging Face Transformers library. They were running us through some NLP related tasks. One of them was sentiment analysis. So that would tell you if it's like a positive statement, negative statement, or I think there's also neutral. I don't remember, but yeah, stuff like that. Basic NLP tasks. I did some of them through what do you call it? Through Hugging Face Transformers, but I haven't really done NLP, if that makes sense. Like I've done these very basic NLP tasks, and to accomplish them, I just use the Hugging Face pipeline object. I specified the task, I specified the model, and then I gave it input and got my output. But I feel like I don't know too much about NLP, and that's kind of where I want to start. I want to learn NLP. And this brings me to another thing that another, let's say, study endeavor that I need to set up, that I need to get into. Give me a second. I need to open up my stream on my phone so that I can see the chat. So just hold on for a second here. I'm going to open up my stream manager and open up the chat, and we are good to go. All right. So what was I saying? Shit. I forgot what I was saying. Oh yeah. So another study endeavor that I want to take on, and I've mentioned this in previous streams. I've mentioned this in previous streams. We've talked about this in previous streams, but I never actually got around to creating the prompt for it, or even just getting an idea of the syllabus. And then today I decided to talk to Gemini about it in one of the conversations, and I believe this is that conversation. Yeah. So, so I did this, but I also did another thing, which was, hold on, where is? Just give me a second. I need to look for the conversation. Where did I put that? Explain these first. No, this is not what I'm looking for. Perhaps this is what I'm looking for. Give me a second here. Yeah. Yes. Okay. So, this is my prompt that I gave to Gemini CLI, and I said, "Hey, I'm working on an." Should I read this entire thing? It's a very long thing, but basically what I said is that, "Hey, I'm working on an auto clipper to clip my Twitch VODs. So far, the workflow that I have down is I'm going to take the MP4 container, I'm going to extract the audio from it, and then I'm going to transcode the audio to WAV. Then I'm going to feed that WAV file into distill small en, which is our transcription model. And I was trying to think of the name. It's our ASR model, our automatic speech recognition model. Uh, HX, hello, welcome to the stream. How's it going? We are just talking about some NLP related, actually NLP tasks in general, NLP tasks that I want to perform on my VOD transcripts. So I set up this prompt because we had this information which was very useful, which gave us the idea that, okay, we generate the transcript. The transcript contains. Do you speak Hindi? I hear your accent. I do, but I like to keep the stream in English so that everyone can understand what's being said. But yeah, I do speak Hindi. So, uh, this information that we got from Gemini previously, in this information, it explained, I actually didn't finish reading this part, which explains the six different tasks, which are text classification, zero-shot classification, token classification, sentence similarity, summarization, and text ranking. Can I write in Hindi? No, I would prefer if you wrote in English because I want to keep the chat to English so everyone can understand what's being said. Um, what was I saying? Yes, text ranking. So these are the six different NLP tasks that I looked into, and aside from these six tasks, I feel like uh, bro, there are two viewers. I don't think anyone cares. That's okay, but I still want to keep the chat to English. So aside from these six NLP tasks, um, I want to learn if there's other tasks that I can perform on the transcripts to get some useful information. And it turns out there are a bunch of useful tasks that can be performed. One of them is called topic modeling. And topic modeling, I feel like through topic modeling, I can get the labels that I was looking for zero shot classification. Um, but other than that, I need to look into if there are any more tasks that I can perform because in the conversation here, yeah, in the conversation here, and actually in the Gemini web conversation that I had as well, Gemini did mention a couple of separate tasks. Summarization is one that I didn't mention to it. Yeah, summarization is one that I didn't mention to it. Oh, keyword slash key phrase extraction. Yeah, that's also one that I need to look into. Topic modeling was mentioned somewhere here. I can't remember. Maybe it was in the Gemini CLI conversation. Hold on. Keyword. Oh, yeah, here it is. Additional NLP tasks to consider. Keyword slash key phrase extraction, abstractive summarization, and topic modeling. Give me a second here. Okay, so um, I'll read this, but then I also want to read. Hold on. Hold on. Where was the conversation? The conversation was somewhere over here. So I was asking Gemini about how I can connect, um, how I can connect deep learning and um, how I can connect deep learning and NLP. So I mentioned that okay, I want to learn um, feed forward neural network, convolutional neural network, recurrent neural networks, and transformer based neural network architectures in deep learning. These are four architectures that I'm focusing on. Um, what was I saying? Yeah, these are four architectures that I want to focus on. And I know in deep learning that I want to focus on these architectures, but like in NLP, I don't really know what exactly I'm trying to learn there because I don't know NLP to begin with. So I feel like I need to learn the basics, um, and then apply deep learning to those basic concepts, or uh, learn basic NLP tasks and then apply deep learning to solve those kinds of problems, to accomplish those kinds of tasks. So I asked Gemini to generate this sort of syllabus for me. At some point today, we're going to read through this syllabus because, and I think I'm also going to export this because there's some good information here. I can later on probably generate a, a sort of course based on this. I'm not sure. However, for now, we're going to read through, where is it? Uh, Here. So I told Gemini that okay, I'm working on this auto clipper, and so far the workflow that I have set up is that I'm gonna extract the audio from the MP4 and transcode it to wave, and then feed that into an ASR model to get the transcripts, and then I'll analyze the transcripts by first. Actually, no. Let's not get into the analysis first. After getting the transcript, I'll divide it up into chunks, into 60-second windows, with a difference of like 30 seconds each, a difference of 30 seconds between each window. So it's going to be a sliding window with a stride of 30 seconds. A 60-second sliding window with a stride of 30 seconds. That's a better way to put it. What was I saying? What was it? Oh, 60-second sliding window with a 30-second stride. Okay. So now this, up to this point, I've got it set, right? I know what I'm doing up to this point. Even the sliding window thing, I need to work on that implementation. I am probably going to work on it today, if possible on stream, but definitely off stream. I'm going to finish working on this. And the result of this is supposed to be Boolean, it's supposed to be Boolean indices or Boolean indexes, or it's supposed to be lists of Boolean indices or lists of Boolean indexes, because we're going to be using Boolean indexing to get the chunks, and rather than storing the chunks, or bundles, groups of the chunks as individual groups, it's much better to store lists of the Boolean indexes. And then each time so each of these lists is going to represent one window. So anytime I want, I can pull out, a set number of records. So that's going to be our entire windowing mechanism. Further from that point, I don't really know how I'm supposed to approach this whole thing. So further from that point, I need help here. And the reason I set up a new prompt for this is to understand how to do this specifically for informative streams and educational streams, because I noticed yesterday that in the other reply, which was this one, I believe, so Gemini did mention that, yeah, there's interesting content, there's educational content or whatever, but Gemini also mentioned emotion stuff like sentiment analysis, look for moments of excitement, or look for, I don't know, laughter, look for certain words that are close to like entertaining concepts. Um, Hold on, give me a second here. All right. Okay. So, what was I? Yeah. So what I noticed is that in this explanation, like for example, if you see here, Gemini suggested this thing, like look for spikes in key emotions. Hold on. Yeah, look for spikes in key emotions like joy, surprise, or even anger, which can be very entertaining, right? Let me see if I can find other examples. Stuff like this: funny anecdote, game strategy, reacting to chat, and then it also mentioned technical explanation. But this gave me the idea that maybe Gemini is not sure about what kind of content I'm making. And so, sorry, zoned out. Okay, what was I saying? Yeah, I don't think Gemini fully understands what kind of content I'm making. And so rewriting the prompt and explaining that, okay, this is the specific type of content that I make. It's not like, funny or entertaining or like very high energy kind of content. Usually it's very chill, very, well, I wouldn't say very informative, but it's definitely informative. Sometimes educational, and generally it's me studying something or building something. So, like, that's the kind of vibe in the stream, right? Based on that, what exactly, what types of NLP methods should I be applying, and how should I be applying them to the transcript in order to get some useful information out of it? So I asked that question here, and now I guess we can read this. Okay, that's an excellent step you have for extracting audio and transcribing it. That's an excellent setup you have for extracting audio and transcribing it. The sliding window approach with 60-second chunks and 30-second stride is a solid starting point for breaking down your VODs into manageable analysis units. For is a solid starting point for breaking down your VOD into manageable analysis units. Okay, given your content, study slash work streams, informative, educational, here's how I'd recommend approaching the NLP tasks you mentioned, along with, you know what? Okay, hold on. Yesterday I noticed this thing as I was reading through the explanation that Gemini had given. I noticed that what we were doing was sort of taking chunk by chunk, like every 60-second chunks, right? But like they're overlapping chunks. It's not like separate 60-second chunks, they're overlapping chunks. And we are getting a score for it. So we are kind of getting, I don't know what's the right term to use there other than average. We are getting kind of an average. We are getting an idea. We are creating values over time. Um, or how do I even say it? What am I trying? I know what is being done. So like, okay, let's say we have 5 minutes worth of footage, okay, or 10 minutes worth of footage. We divide that up into 60-second chunks. So 10 minutes would be 600 seconds. Um, 600 seconds would then be uh, 10 chunks, right? But no, it's 60-second chunks, but the stride is 30 seconds. So what would that be? 1,200, I think. Yeah, I think so. I think so. Anyways, so what we are doing is we are essentially giving a score over time for this entire chunk. So this is like continuous data that we have, and we are giving a score to like the continuous data by analyzing overlapping chunks. That's the important part, that it's overlapping. So that's why there's like a connection between you know, two two chunks. Um, so like for this chunk, we are essentially giving this entire group of text a rating over time for a specific type of signal. We are giving it we are assigning a signal for it over time, over its duration, and at any given time we are specifying the power of that signal. I find that really interesting. That's a very interesting way of analyzing some data. This is a way that I've never used before, and I need to talk to Gemini about what this method is really, what this method is, and where all does it get used? What are the pros and cons of this method? Because this is actually a great way to analyze a big bunch of data when you don't want to analyze, when you cannot, for whatever reason, analyze individual things within the data. For again, whatever reason, maybe it might be too expensive to analyze every single thing. So instead, you take like chunks of it, but like overlapping chunks, and you get a sort of idea of it over time. Okay, where was I? Manageable analysis units. Okay, given your content, here's how I'd recommend so and so, so and so, um, along with some additional suggestions and a discussion on models. Recommended NLP tasks and approach. Your goal is to identify segments that are informative, educational, maybe interesting. This requires a nuanced understanding beyond simple positive/negative sentiment. Okay, zero shot classification, highly recommended. Why? This is probably the most powerful tool for your use case, especially without a large amount of labeled data. You can define categories like explaining. You know what? Yeah, I should do that. I should look into zero shot classification models and then test them out using my own like sentences and give them like different labels and see what scores they return. That would be something interesting to try out. Yeah, yeah, that would definitely be something interesting to try out. I can then even plot the scores on like a um what do you call it, a horizontal bar graph. I can plot the scores on it. Yeah, dude, I should test out each of these like individually. Is this text an explanation of a technical concept? Does this text describe a problem solving Okay, hold on. Zero shot classification, especially without a large amount of labeled data, you can define categories like explaining concept, debugging session, problem solving, planning next steps, idle slash off topic. Okay. For each 60-second chunk, classify it against these custom labels. For each 60-second chunk, classify it against these custom labels. The model will tell you how exactly each chunk belongs to each category. Okay, so for zero shot classification, um, we need these labels. How do we generate these labels? I think okay, let's continue reading and see if I can find ways to generate the labels, because that process has to be dynamic as well. Because like depending on what is being talked about, what is being done during the stream, we're gonna have different labels that have to be scored against. But okay, like explaining concept, debugging session, so and so, so and so. Okay, for each 60-second chunk, classify it against these custom labels. The model will tell you how likely each chunk belongs will tell you how likely each chunk belongs to each category. Okay, this directly addresses informative and educational. Example prompts for LLM. Is this text an explanation of a technical concept? Does this text describe a problem solving process? Does this text discuss future plans or goals? Okay, output. You'll get scores for each label, which you can use to prioritize chunks. Okay. So what I'm thinking is like, okay, if we are able to extract pieces of information from, um, let's say, I don't know, so we are going through this in like 60-second chunks, right? We have 60-second chunks with 30 seconds gap between the start position of each chunk. So with like a 30-second stride. Um, what we could do is we could start generating labels for any given like I don't know, every 10 minutes. We can divide it up into 60 seconds worth, but then we can take like 10 or 20 minutes worth of. Well, no, hold on. For the clip, we're going to do one thing, right? For for the highlight, we're going to do another. So we need to set hard limits for each. So the clip is supposed to be anywhere between between 30 seconds and 5 minutes. because after I cut it down, after I slice out all the silence, it might become like, 2 or 3 minutes. Maybe I should make that between 30 seconds and 4 minutes, because then when I slice it down, it's going to become um, somewhere between 30 seconds and 3 minutes. Yeah, yeah. And then the bigger one, the for the highlights, we can do between 5 minutes and 20 minutes. Or we could do 5 minutes and 30 minutes. I feel like that would make a very long video. I'm not sure. But like here's okay, I'm kind of getting an idea of what I want to do here, but I'm still like, because there's a bunch of things I have to do, right? I have to figure out what topic is being spoken about, and then I have to figure out from what point to what point this topic is still being spoken about. Yeah. I need to figure out like how from where to where the topic is being still spoken about. And I might run into a problem here because I tend to branch out a lot. And so I might be talking about a certain topic and immediately I'll like interrupt myself and start talking about a different topic and just like branch out. And then later on, I might come back to this topic. But then I don't know if I'm going to catch that in the analysis. Yeah, if it's like a broken discussion, like a discussion that branched out and then it merged back in, I don't think my logic is going to catch that. Yeah, I don't think my logic is going to catch that. If it's a discussion that's happening like in one go, then yes, I can continuously keep analyzing what topic is being spoken about, and then analyze how long the topic is being spoken about, and then cut out that segment. So that becomes one clip or one timestamp or something else. One clip or one timestamp, one clip or one highlight, um, which I can then slice out. Okay, next, text ranking, highly recommended. Why? After the initial classification, you might want to rank the informative chunks by how well they fit criteria like clarity, depth, or relevance. How? Define a query or a set of criteria, example, text that provides clear and detailed technical explanations, segments demonstrating insightful debugging strategies, then rank your zero shot classified chunks against these queries. Okay. Output, a ranked list of chunks indicating which ones are most relevant to your clippable definition. I think I need to get an LLM to generate these queries and even the labels that were mentioned above. But see, the problem is we end up in a sort of circular kind of thing because at some point later, I'm going to be actually no. We when we are generating the metadata, we have to when we are generating the metadata, we have to generate a summary for this. So then, based on the summary, I could say, hey, come up with like, okay, I have this summary, but this summary is for a 2 hour VOD transcript, or I can read the total number of seconds in the timestamps, and I can give it the exact time and say, this is how long the transcript is, and throughout this transcript or throughout this VOD, these are the activities that we've been doing, and then I'll give it the summary, and I'll say, okay, based on this, come up with some No, dude, I don't think that's gonna work. Yeah, I don't think that's gonna work. That's not no, that's not a good idea. What I was gonna say is that okay, based on that, generate these labels that I can use for zero shot classification and text classification and so on. No, zero shot classification and text ranking. Um, but I don't think that's gonna work out very well. I'm gonna have to divide this up into say 30-second, no, 30-minute windows. Yeah, I'll divide this up into 30-minute windows. And as long as we are within a 30-minute window, based on that 30-minute window, I'm going to ask the LLM to generate a set of labels that we would then zero shot classify against and probably text rank against as well. That could work out because I need to find ways to automate this. But then we don't necessarily talk about the exact same thing in every single stream, right? So to extract the information and generate labels, I feel like an LLM would probably perform the best if I give it the right prompt and I make sure to use outlines because outlines is the only way that I'll be able to get structured output, which in this case, I'm looking for something like, you know, um, something like a dictionary with a list, and the list contains, or not even a dictionary, it can just directly be a list, and the list contains all of the labels, and then I can directly feed that list into a zero shot classification model. Then based on that, I'll get the score, and I can note down the score. Okay. Uh, Define a query and so and so, so and so. Then rank your words. Rank your zero shot classified chunks against these queries. Rank your zero shot classified chunks against these queries. So first we rank them against the labels that we set up in zero shot classification, and then we rank them against these queries. And I guess, well, I guess these queries can also then be, um, generated by the LLM because this is like definitely, a whole lot of natural language. So I can just get the LLM to do this for me. Right. Wait, hold on. Did it mention the output? The output is a ranked list of chunks indicating which ones are most relevant to your clippable definition. Okay. Now, I feel like there's different approaches that I can take here. One is going over the entire VOD and getting a list of labels to rank against and a list of text queries to rank against, and then classifying all the chunks against those labels and queries. And I'm going to have to make sure that the chunks are contiguous, not uh, not like spread all over the collection. So it shouldn't be that, two or three chunks are in like the 5 minute mark, and then there's, I don't know, four or five chunks that are talking about the exact same topic, but they're like half an hour later. So I can't like join these two into a clip. It's not gonna make sense. I need to make sure it's like uh, one contiguous array of chunks where the topic is continuously being spoken about. So I guess that's where sentence similarity comes in, doesn't it? Like we want to make sure that the score for sentence similarity remains, um, above a certain threshold, and then once it goes down past a certain point, we assume that we've stopped talking about this, and then like we stop the clip right there. Though I could use sentence similarity um to chunk the chunks or group the chunks into discussion labels. So I can then label groups of chunks as being, speaking about so and so topic. I like that idea. I like that idea. I'm going to have to set up a different logic for clipping and a different logic for highlights, or different logic for clips and different logic for highlights, because one is supposed to be between 30 seconds and 3 minutes, and the other is supposed to be between 5 minutes and 20 minutes. So I'll have to set up different logic for each of them. Maybe also different like chunking mechanisms. I'm not sure. I mean, for me, it's more like they're both supposed to be able to do the exact same thing. It's just that if the content is small enough, it becomes a clip. If the content is longer than what a clip can be, then it's a highlight. That's the basic. That's the basic idea. That's the logic that I'm following. So, um, for the most part, they're both supposed to operate in the same way, except they might be analyzing bigger or smaller pieces of data based on what it's supposed to be, whether it's supposed to be a clip or a highlight. Okay, then next is text classification. If you can collect data, why? If you do eventually get some labeled data, example, you manually mark some chunks as good clip or bad clip, a fine-tuned text classifier would be very accurate and efficient. How? Train a model on your labeled data to directly classify chunks as clippable, highlight worthy, or discard. Okay. Yeah, I feel like here Unicorn, hello, hello, welcome to the stream. I do speak Hindi, but like I prefer to keep the chat to English, just so anyone else who might be coming into the chat, they can understand what's being said. But yeah, I do speak Hindi. Welcome to the stream. Hello, hello. We are currently working on the logic for um, analyzing VOD transcripts. I'm trying to analyze the transcripts to understand how to or to figure out ways to identify clippable moments. Yeah, yeah. So I'm just talking to Gemini about different ways that I can use NLP to analyze the transcripts. So we are currently on text classification. Oh, yeah. Uh, yeah, that's okay. If you're looking for a stream that's in Hindi, I'm sure you'll find. If you look in the Indian tag, then you'll probably find people who speak specifically in Hindi. Okay, where was I? So I was saying, okay, as I work more on this logic, what I could do is I could hold on to the data that I generate during the analysis of each of the transcripts. Like even after the clipping is done, I can still hold on to the data because that data is telling me that, hey, so and so text is classified as so and so thing, so and so text has so and so label so-and-so, group of text has so-and-so summary, and so on. So I think once I start analyzing each of these VOD transcripts, I'm definitely gonna hold on to all of the scores that get generated by the various NLP tasks and stuff. I have to. I don't know how I want to store this because yeah, I need to store it in a generic way, if that makes sense. I need to store it in a way that um, different types of transcripts can have different labels and scores attached to them. And then I can still later on iterate over all of the data within a file and just read the labels and transcripts. I guess what I could do is I could create like a dictionary object and write that dictionary object to the file. So each of the chunks that I'm not each of the chunks, but like each of the labels that's being generated for the various chunks and each of the labels that's being scored against, that can be stored. So it can be like because dictionaries can have, I believe dictionaries can have dictionaries within them, right? Give me a second here. I think it's this one. Yeah. So I need to select the session here. I think it's this one. It was not this one. It was this one. Yes. Okay. For a second there, I was concerned that maybe I lost the entire session, which is, I mean, it's not that big of a deal. It's just a bunch of files that's open. I would have to open all of these files again. So it would just be that minor inconvenience. What was I going to do? Oh, yeah. I just remembered. Uh, okay. So let's comment that. And then down here, let's do A equals, well, it doesn't have to be a data frame. It can just be a dictionary. Or let's say sum underscore dict01. And we can do this. And in here, we can have another dictionary, which is going to be, I don't know, A underscore 1, 1, 2, 3, 4, or just 1, 2, 3. Okay. Hold on. Right. And then I can copy this entire thing and paste. And now we make some changes here. So B, 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 B. Okay. So far, we are not getting any errors. So now we can do sdo1 underscore JSON equals JSON dot dumps or loads dumps. JSON.dumps, and we pass in our object into this and give indents. 4, and then we print out sdo1.json. So we should have a proper JSON or proper, like, a structured dictionary thing. Yeah, there it is. So this is our JSON data. So just like this, I could store all of those scores into like JSON files, and later on I could retrieve all of that data from those files. I'm wondering if there's like if I should be trying to use other methods to store this. I'm not sure. Dude, at some point I should definitely learn, because JSON is a very simple language, right? It's a simple yet powerful language. Um, you can have like you can either have, because like I can even serialize a list if I want, and that's accepted as well. So if I say I don't know, let's say temp01 equals JSON dot dumps, and then 1 2 3. Actually, let's make it 3. Will it accept like empty dictionaries? I think so. Okay. So we can change this to temp01. So that's our dictionary. So you can even serialize a list into JSON. That'll make it an array, and you can have dictionaries. Lists can have dictionaries. Dictionaries can have lists. You can represent, I believe, even like classes. They get serialized into a similar form, and a similar form as dictionaries. In fact, if in Python, if you are trying to serialize a class and an object of a certain class that you've made, usually you would be doing usually you would be using asdict, the asdict method. I don't remember what it was. Hold on. Class MC01. And then here we can, I mean, yeah, it doesn't matter. We can create the details later on. So let's say A equals MC01, and then A dot sum 01 equals 5. We can do, I mean, this is giving an error, but we are allowed to do this. At least from what I remember, we are definitely allowed to do this. It's going to throw an error, probably because the members haven't been defined, but Python does allow you to do this. So if I run this now, we shouldn't be getting an error. Yeah, okay, we're good. Right, so then we do print, no need to store the thing. Actually, okay, we can do a underscore JSON equals JSON dot dumps a, and we can also do indent, and just to make it look a little pretty. So save. Oh yeah, there's our problem. We have to do as dict or underscore dict. I think it's this underscore dict. I don't know if this is a function call or it's just a variable. Okay, this returns a dictionary version of the class, and this is how you serialize a class in Python, a class object. Basically, it's just a dictionary. Why was I talking about this? I was saying that I also need to learn Tamil because JSON is a very simple language, uh, and it has its merits, it has its benefits. One massive benefit is that it is very human readable, where apparently Tamil isn't necessarily the most you can read it, but like I don't know, maybe it's not as intuitive because you don't have a whole lot of explicit grouping going on in Tamil. Um, how do I explain this? So you have indentation, I believe, not indentation. I think indentation is a thing. I'm not sure, but you usually specify like labels, and I don't even know the Tamil terminology for this, which is why I want to learn. I want to learn the Tamil syntax. Not that I'm going to be writing, raw Tamil. It's not like I've had to write raw JSON in many situations. I've written raw JSON, but like it was just like, okay, I needed something real quick, and that's why I wrote the thing down. So knowing how to write JSON, knowing how to write very basic JSON, it has helped me. For example, because of knowing how to write raw JSON, I was able to uh, do something like this, where I just created a JSON file and wrote down this entire dictionary to create a sort of metadata template. What was I what was I saying? Yeah, I'm not entirely sure if Tamil is all that intuitive in that aspect, in that sense. It does take up less space apparently than JSON, where JSON might have extra characters for stuff like um, you can see double quotes for the keys of the dictionaries. You can see the curly brackets for the opening and closing of the dictionaries, and so on. You're going to have like multiple examples like that. Tamil ends up being a little more compact in that sense, but then this, because of how verbose it is, it's a lot more readable. Still, I want to learn Tamil syntax as well because I have been in situations where I had to modify um, I had to modify Tamil files, Tamil config files, because there are various Rust-based projects that use Tamil, specifically Tamil config files, and not knowing the syntax, it can sometimes lead you to lead you into situations where you have errors. Okay, so why was I doing this? I forgot why I was doing this. I think I was talking about that. I was talking about the fact that I need to record all of the scores. Um, the thing is, I'm gonna need to make sure I would be relying on the model's output. I'm gonna be no I'm gonna how do I say this? I'm gonna be relying on the model to make accurate um, predictions, accurate classifications. So if the model is saying that, okay, these are the lists of labels that I've determined um, belong to this chunk of or this group of chunks of transcript, I'm just going to be taking its word for it that, hey, yeah, this is what's going on. This is what was analyzed, and that is why I definitely want to use um, some of the bigger, more trusted models. Trusted in the sense that we know that they're going to be accurate because I'm definitely relying on their accuracy in order to generate my own data. I don't know what I'm going to do with the data yet. I haven't decided. I haven't decided what, if anything, I'm going to be doing with that data. But in the future, because I'm basically processing every single one of my once the content pipeline is completely ready, I'm going to be processing every single one of my VODs through that content pipeline. Regardless whether I get interesting information out of it or not, I'm definitely going to be getting a lot of very interesting NLP related data, meaning I would then be able to, in the future, if need be, I would then be able to set up a data set out of this and perhaps fine tune a model with this data. So I mean that's for the future. For now, I have to first collect the data. And hey, I mean, who knows? If my data set ends up working out well for me, because this is text data, this is not audio data, so um, I don't need to worry about like whether it's going to recognize the voice or the wordings or the accent or the way of pronouncing things or the way of structuring sentences or gaps in between all like spoken language related things. I don't need to worry about all of that being an issue. Um, it's going to be mainly analyzing transcripts which are in text form. So anybody who is doing similar streams, actually, I mean, I could collect this data. I could generate the scores, and then I could share the data. I don't know what anyone is going to be able to do with it, but what I do know is that the result of the calculation, the result of the processing that I'm doing, is going to be a whole bunch of labels and a whole bunch of text associated with those labels, and certain scores that have been given to each of the labels. So once I know more about NLP and LLM related tech, then maybe in the future I'll be able to do something with this data. And besides, I mean, why throw away the data when, like, we are spending we are spending we are spending computational effort, let's say, if that makes sense. We are spending the time generating the data anyways, right? We are spending a certain amount of resources. Fortunately, in our case, it's not money, but like resources are being spent. Just fortunately, in our case, it's not money because shout out to Kaggle, we are getting these resources for free. Um, but there are still resources being spent, right? Actually, that is all the more reason. Now that I think about it, this could be our way to give back to the community, right? Because I'm using their resources to analyze this data and generate certain types of structured output based on that. So I could then later share this data set online, and um, yeah, yeah. I don't know if if I'll be sharing the entire transcript of the VODs. Yeah, I don't know yet if I'm going to share the entire transcript. However, whatever the NLP tasks generate in terms of like labels and scores and stuff, that I can definitely share. So chunks of the the transcripts, along with their associated labels and all of that, can definitely be shared. Give me a second here. Actually, yeah, wait. Give me a second. I need to, because like the machine on which I have another stream running, the stream seems to have crashed. So I'm just going to try and fix that. And in the meantime, I need to, well, I need to hydrate because I've been talking for a good like hour now and I haven't hydrated. So give me a second while I hydrate and also fix this issue that I'm having. Okay. All right. Hold on just a second. I'm still trying to fix that other issue, and then we will get right back to this. But yeah, I'm glad that I thought about saving the data that's being generated, because I was just gonna throw away the data, but yeah, I'm glad that I thought about saving the data, and I can put it up on both Kaggle and GitHub. I think so. Though I think I feel like putting it up on Kaggle would be enough. Or I could put it up on Kaggle and because I feel like, dude, I feel like NLP related. Hold on just a second. I feel like NLP related stuff. Okay, so I was about to say that I feel like NLP related stuff is probably going to be a lot more on Kaggle, but then that's not entirely true. There's like a lot of different types of data sets, and there's a lot of different like data science related stuff um, on there. Hold on. Let me ask this question, because three places that I can think of right now in terms of sharing data sets are first of all GitHub, my own GitHub, but then also Kaggle and Hugging Face, because Hugging Face doesn't just host models; they also host data sets. So you can share data sets on there. You can also download data sets from there. And Kaggle definitely it allows you to host data sets and also download data sets from there. With GitHub, I'm not sure what the limit would be, because GitHub is more for code sharing. I mean, you can share like other stuff as well, definitely. No, I mean, yeah, if it's a whole bunch of like text files, I don't think my size is going to be that big, so I don't think I need to worry about it. So it'll work out. But I don't know if people usually go on GitHub to look for data sets, if I'm being honest. I can put it up on GitHub, but I don't know how useful that's going to be. It's just going to be like, hey, here's a data set that I've put up, but like I don't really know how many people are going to try and access it through that. If I do put it up there, it's probably going to be like a mirror of the other data set. So it's going to be like, oh, this is like a vault. I'm just storing it here. If you want to actually use it, you can probably use it from Kaggle. I could do that. I could host it on. Wait, let me open up a new conversation with Gemini and ask this question. Hey, so doing a bunch of data science and deep learning studies. I am currently working on a project that is going to be doing a whole bunch of NLP related analyses and generating labels and scores. Generating labels and scores for chunks in transcripts. I feel like others might be able to benefit from all the data that, oh wait, let me also mention this. I'm gonna be using all this. No, I'm gonna be doing analysis on the transcripts of my Twitch VODs. Okay. I feel like others might be able to benefit from all the data that's gonna be generated by the various NLP tasks I'm gonna be performing. Uh, performing. So I want to set up a data set and upload it online for people to be able to use or study or whatever. I'm kind of torn between putting it up on GitHub, Kaggle, and Hugging Face. Well, dude, considering Kaggle is the data science platform, maybe Kaggle is a better option. I'm not sure. Okay, that's a fantastic project. Twitch VOD transcripts are a goldmine for NLP. You've got slang, multi-user interactions, and time series sentiment all baked into. Oh, I was wondering. Hold on. Earlier in the stream, I was wondering what would the terminology be for this thing where we are generating scores over a certain period of time, like scores of overlapping chunks, in order to. Something just happened. Hold on. I'm not sure what just happened, but I think we are good. Okay. Yeah, I was wondering what this kind of analysis is called. I think this comes under time series analysis. I think so. I'm not sure. And there is also like a whole separate section in the Kaggle Learn section for time series analysis. Okay, so since you're at the intersection of deep learning and NLP, the choice of platform really depends on who you want the quote unquote customers of your data to be and how you want them to interact with it. Comparison, GitHub versus Kaggle versus Hugging Face. Hugging Face is the gold standard for NLP. If you want your dataset to be used in modern deep learning pipelines, this is the winner. It is essentially the GitHub for AI. Best for NLP researchers and practitioners using libraries like transformers. And the killer feature is the dataset viewer. Yeah, dude, I forgot about that. Wait, oh yeah, that was in. I was wondering where that feature went. I was looking at the wrong platform. It wasn't Kaggle. It was Hugging Face. They had like a dataset viewer where you could view different types of datasets in a not just a tabular form, but like there was more interactivity in it. Okay, anyways, the killer feature, the dataset viewer, people can preview your transcripts, labels, and scores directly in the browser without downloading anything. integration. Users can load your data with one line of code using load dataset. Okay. And cons, it's not great for hosting non-ML code or general project management. It's not great for hosting non-ML code or general project management. Then Kaggle is the community hub. Kaggle is where people go when they want to play with data. It's a very social environment for data science. It's best for exploratory data analysis, visualizations, and getting community feedback through notebooks. The killer feature, kernels, notebooks, you can write starter notebooks showing how to analyze the scores you generated, and others can fork it to create their own versions. Visibility, it has a massive built-in audience of beginners and enthusiasts who love unique data sets. Cons, less integrated into programmatic training workflows than Hugging Face. That is true. Yes, that is true. Yep, that is actually true. Because like with Hugging Face, you have Hugging Face transformers, Hugging Face datasets, and various other such things, right? They let you interact directly with the Hugging Face hub in different ways. You can download models, you can download datasets. I think through these libraries, you can also upload models and datasets. I don't have the full details on that yet, but I believe there is a way to do it. Or I think it's through their, they have a separate thing called HF Hub. I don't remember. Whereas with something like Kaggle, you would usually be uploading your entire code to some kind of notebook through their API. So through your local Python code, you would upload some other Python code that you've written, which is meant to be run in a notebook, and that entire code gets pasted, posted, pasted. It gets put into one code cell, and then that code cell runs, and the output is then given to you once the running is complete. Where was I? Cons, less integrated, so and so. Okay, then GitHub, the developer's home. GitHub is great for the code that generated the data, but it's not actually a data hosting platform. It's best for, you know what? Okay, that's true. Anyways, I was planning on putting up this entire content pipeline on GitHub. So I could just link it in the data set. I can be like, yeah, this is how it was generated. So you get to see the code for um, how these data sets were generated. Okay, but it's not actually a data hosting platform. It's best for versioning your analysis scripts, readmes, and small sample files. The killer feature, it's the industry standard for version control, but the cons, it has strict file size limits, usually 100 MB per file. If your transcripts grow, you'll have to deal with Git LFS, which can be a headache for users to download. Okay, all right, that's good enough for me. Let's continue reading this thing. Okay, sorry, zoned out. Okay, Where was I? Text classification. If you do eventually get some labeled data, give me a second. I'm just loading this thing back up. Yeah, I think I'm done reading this, right? Start with zero shot, and if you find patterns, you can use the zero shot classifications to pseudo label data for dedicated text classifier. Hold on. Train a model on your labeled data to directly classify chunks as clippable, highlight worthy, or discard. Okay. Though wouldn't I be like how would this work when it comes to oh, it says okay, example, you manually mark your chunks as good clip or bad clip, and fine-tuned words. A fine-tuned text classifier would be very accurate and efficient. How you train a model on your labeled data to directly classify chunks as clippable, highlight worthy, or discard. Yeah, but then how are we? Because the chunks are 60 seconds, right? How exactly is how are we determining that 60 seconds is worth keeping? I feel like groups of chunks can be labeled, so I can then, based on some other criteria, I can group chunks together, contiguous chunks together. Hold on. Yeah, we can. I can group multiple chunks together, but they have to be contiguous chunks, multiple like overlapping chunks together. And so I need to analyze chunks for a certain period of time and make sure that the same topic is being spoken about, and like what is the topic being spoken about, and then later I can pass that through a text classification model. But then it based on what's being said here, it has to be a pre-trained model, or like I have to train my own. I mean, I'm sure I can find like pre-trained models for this. Note, start with zero shot, and if you find patterns, you can use the zero shot classifications to pseudo label data for a dedicated text classifier. Okay, so in the future then, once I have all of this data, let's say 1 month's worth of data or 2 months worth of data, that's already going to be like 60 VODs, right? Assuming I'm able to stream for, you know, if I'm able to stream daily and I'm able to continue keeping up this streaming streak, um, that's going to be 60 VODs, right? For this year alone, we already have a good like 40 VODs, I think, or 45 VODs. Let's say 40 VODs, close to 45. Though I'd imagine we would need a lot more than just that. So over time, I'm going to be slowly, analyzing more and more. Over time, I'm going to be slowly building up the data set over time. And yeah, dude, I guess that's what I've got to do. And then later on, I can train my own model once I know more about NLP. And this is actually why I need to learn more about NLP and LLMs. Not even just so I can use the models, but so that I would know what types of what methods I should use for analyzing data. Like, what exactly am I looking for I don't even know what I'm looking for. It's through these tasks that I'm understanding that, oh, I can look for this, I can look for that. But otherwise, I'm kind of lost in terms of what exactly I'm supposed to be looking for in the text that would then make the text be considered clippable. Like it's super easy to just feed the entire thing into an LLM and tell the LLM to determine that, oh, this is useful, that is useful, and so on. First of all, I'm not entirely sure I'll be able to get good quality information, or good quality clips, I should say, out of that. I'm not entirely sure I'll get good quality clips. Um, that's not to say that I'm expecting good quality clips with my logic, but like if I know what I'm looking for, if I know what I'm doing, if I know the various analysis steps that are being followed, I can then I'll know that yeah, the clips that are being generated are going to be good quality or interesting or whatever. Okay, we can move on from text classification. Then we can look at sentence similarity. Why you should use this to find chunks that are similar to the seed sentence or a collection of sentences that exemplify interesting content from your streams, or to group similar discussions together. How embed a reference or a good clip description, example, explaining React hooks clearly, and compare its embedding to the embeddings of all your chunks. Chunks with high similarity are are good candidates. Also, good for identifying repeated concepts, or if you have a specific topic of the day you want to extract. Then sentiment analysis. Use with caution. Why? Standard sentiment, standard sentiment, Standard sentiment might not be ideal for informative content. Positive sentiment could be general positivity, not necessarily informative. However, a highly specific sentiment analysis, example, detecting aha moments, successful resolution, or even frustration leading to a breakthrough. I've had that. Yeah, I've had situations like that on stream where like we figured out, a certain problem that we were trying to solve, or we finally understood a concept that was like, oh, how does this work, and so on. Yeah, yeah, definitely. We've words. We've definitely had those kinds of situations. Um, okay, how? Apply a sentiment model, but interpret its results carefully in the context of your stream type. Look for peaks in positive sentiment during problems. You know what? Okay, this can be one of the like added signals. This could be one of the extra signals that I could throw in, that would maybe somehow help with classifying something as interesting, or it would help with something. I'll apply it. I'll apply it. Look for peaks in positive sentiment during problem solving rather than just overall positive chunks. That's a good idea, actually. So I could check for like, okay, during specific time periods, or during time periods of a specific type of activity, what was the overall sentiment? Then token classification, less direct for your main goal. Why? This is more for tasks like named entity recognition, where you'd want to tag specific entities, example Python, TensorFlow, VS Code. While useful for understanding what's being discussed, it's not a primary driver for identifying clippable segments directly, though it would be a feature for another model. I could still run, because I was looking for things that it could like recognize, right? So what I could do is I could use this to generate a list of How would I plot that though? Yeah, that would be a little complicated to plot because if I have a bunch of different labels, I mean, at the very least, I could generate a list of labels that it finds, and then I can use that as like a cue of some sort, a hint of some sort for, hey, okay, during this section, during this segment, we are talking about so and so things. So, look into that and see what's going on there. I can still run this and see what results I get. Okay, then additional NLP tasks to consider. Keyword slash key phrase extraction. Why? Automatically pull out the most important topics and terms. This is more important for me than NER, which is up here, token classification. I feel like this would give me something more useful. Okay, automatically pull out the most important topics and terms for each chunk, from each chunk. This helps you understand what the chunk is about and can serve as a feature for your ranking slash classification models. There you go. That's what I was thinking about. This can help to, I kept using the term label, but like, yeah, this can help generate features for the classification models. How? Use models like text rank or those based on transformer embeddings, etc. BERT topic. Okay, I can do that. Actually, let me look into that because I will be using transformer based models mostly because I'm running all of this in the cloud, so I have access to these resources. So, why not? BERT topic. Is BERT topic even hosted on? Yeah, yeah. BERTopic is a topic modeling framework that leverages transformers and CTF-IDF to create dense clusters, allowing for easily interpretable topics. Okay, um, interpretable topics whilst. Anyways, keeping important words in the topic descriptions. Okay, it supports all kinds of topic modeling techniques. Oh, there are different topic modeling techniques. There's guided, supervised, semi-supervised, manual, multi-topic distributions, hierarchical, class-based, dynamic, online slash incremental, multimodal, multi-aspect, text generation slash LLM, zero shot, which is apparently a new one, merge models, and seed words. That's crazy. That is crazy. Using bird topic. Wait, there's like a separate documentation thing here. So where is this from? Hold on, I'm scrolling down to see where exactly. Um, yeah, because this seems like a separate thing that needs to be installed. So from Burtup, what is the documentation that I'm looking at right now? Because it's not even showing. Um, where's the Burtopic model? Burtopic Hugging Face. So there's documentation for using it, introducing Burtopic integration with the Hugging Face hub. Models compatible with the Burtopic library. Um, okay. Oh, dude, yo, this is interesting. Hold on. I need to show you guys this. Hold on. This can definitely be useful. Get started with bird topic and hugging face. Okay, we are thrilled to announce a more significant update to bird topic Python library, expanding its capabilities and further streamlining the workflow for topic modeling enthusiasts and practitioners. BirdTopic now supports pushing and pulling trained topic models directly to and from the Hugging Face hub. This new integration opens up exciting possibilities for leveraging the power of BirdTopic in production use cases with ease. This was published 3 years ago. Okay. Models compatible with BirdTopic. Wait, that's there as like a search filter. That's interesting. Hold on, I can let me bring it up here. I'm not sure. Give me just a second. Actually, give me more than just a second because my system is uh being a little slow. Well, I can still keep talking about the thing. Well, wait. Hugging face bird topic. So this is apparently a separate library. It's not the same, like this is like a whole separate framework for topic modeling. And wait, let me open this up and open this up. Uh, hold on. I just realized that I'm still on BRB. Give me a second. I'm just switching to that page. Once the page loads, then I can, yeah. Yeah, so this is the list that I was reading out earlier. Apparently, all of these are different topic modeling techniques. And then we have this blog post, which is um, talking about bird topic. And I think specifically bird topic's integration with the Hugging Face hub. Yeah, so hold on. If I go back here, I think I might find like a search thing. Models compatible. There you go. So this is what surprised me. I haven't actually looked. I haven't actually used this kind of a search filter before. Like I've filtered based on tasks and a few other things, but I haven't filtered based on like specific. Hold on, let me show you the filters themselves. Edit filters. Uh, yeah, here. I was confused about what both what was showing up there. But yeah, this is the libraries thing, and here we have bird topic selected. Usually I'm in tasks, and then I'll select, a specific task that I'm looking for. But yeah, dude. Okay, so I've got something to read here. Um, they're explaining what is topic modeling and then what is BER topic. Um, they have this nice animation that's explaining various things. I feel like I can use this, and especially to because I've been looking, like earlier I was mentioning that I need to find a way to generate labels, labels that I can then use for zero shot classification, and it seems like this might be perfect for that. So I can feed in chunks and get it to generate various labels for me. I should also see if I can get it to generate like 10 different labels or 5 different labels. 5 might be better just in case, each of the chunks end up generating their own sets of labels. I can generate 5 different labels for each chunk. Not, it doesn't have to be different, but 5 labels for each chunk. So 5 different in that context. 5 different as in they're not the same as each other. And then in the next chunk, also 5 will be generated. But then it's like, okay, maybe some of the labels might match up with the previous chunk. And then even in the next chunk, we'll generate 5 and maybe the labels might match up with the previous chunk. And so any chunks that are or any labels that are appearing multiple times, in general, we're gonna collect all of these labels and only make a list of the unique labels. We're not gonna add any of the repetitions. We're gonna pull out a unique list kind of thing, and then we can calculate the score of each of these labels. I'll need to find a good pandas or numpy way of doing this, because what we're going to be doing is we're going to be generating 5 labels per chunk, and then we're going to be laying out all of those labels, and then we're going to be summing up the scores of each of the labels from each chunk. And while I could just write, my own for loop for it, I want to see if there's like if there's a more pandas way of doing it or a more numpy way of doing it, because this is like one of the things that they do best, like operating on massive collections of data. Um, yeah, yeah. Okay, keyword slash key phrase extraction. Um, Automatically pull out so and so. And I'm glad that BER topic was mentioned here, because now we actually have something to use. Okay. Abstractive. Okay, wait, now that I think about it, I should look into keyword slash key phrase extraction models as well, because BER topic here is a library. It's not one model. And the library, um, actually, BER topic might also be a model. I don't know. But anyways, the it supports loading multiple different types of um, topic modeling models. So I need to explore if I'm pretty sure there are, so not if I need to explore what other types of keyword slash key phrase extraction models I can find, and if they are any better than what BER topic can accomplish. Okay, then abstractive summarization. Once you've identified a clippable segment, potentially by merging several 60-second chunks, you could use summarization to generate a short, descriptive title or blurb for the clip. How? Feed the full transcript of a chosen clip into a summarization model. Okay, yeah, that makes sense. Okay, then down here we have topic modeling. It's interesting that BER topic was mentioned here, but we have topic modeling here. Okay, understand the overarching themes discussed in your entire VOD or across multiple VODs. This could help you refine your zero-shot classification labels. Yep, that was what I was planning on doing. Or identifying recurring hot topics. That is something I wasn't planning on doing, but I should. I mean, I could just, once I store it and then I um, analyze multiple different data sets or multiple different, yeah, data sets for each like VOD. Once I analyze multiple of them, I can then, get like a hot topic for it. So I can do like a bar graph or I don't think histogram would really count here, but like, yeah, I could do like a bar graph of some sort. Okay, how? Use algorithms like LDA, NMF, or embedding based methods on the full VOD transcript. On the full VOD transcript. Really? Okay, so then it's going to give us like an entire list of labels. Is that how it works? Okay, specialized models versus LLMs with outlines. This is a key decision, and I recommend a hybrid approach, leaning heavily on LLMs with outlines for core decision making. Specialized models, example, BERT-based classifiers, sentence transformers. Sentence transformers is another one that I've been meaning to look into. I'd even loaded the thing up, but then I didn't do anything with it. Yeah, yeah. Okay, pros. Efficiency. Once fine-tuned, they are typically faster and cheaper to run for specific tasks. Accuracy for specific tasks can be highly accurate if you have sufficient labeled data for fine-tuning. And resource usage, generally smaller memory footprint. Okay. Oh, yeah, yeah. Okay, okay. So BERT-based classifier, and so here we are talking about like a specialized NLP model, regardless whether it's transformer based or not, versus an LLM. That's what we are discussing here. Okay. So the pros, yeah, it'll be faster, cheaper to run. It can be highly accurate if you have sufficient labeled data for fine tuning. That might be a problem because I did not plan on fine tuning the model first. Yeah, so I'll have to look into how to go about that. Okay, cons. Requires labeled data for optimal performance and classification. You need to manually label many examples of informative versus uninformative chunks, which is time consuming. Also, it's less flexible, harder to adapt to new criteria or nuances without retraining, and limited nuance might struggle with the interesting or educational aspects without explicit training. Then LLMs with outlines. Pros, flexible. The obvious con would be that it's super heavy. But other than that, what other cons do we have? Um, okay, pros. Flexibility and nuance. It's excellent at understanding complex instructions and nuances in text, making them ideal for tasks like zero-shot classification and text ranking based on abstract concepts such as informative, educational, interesting, etc. No training data needed, zero shot. You don't need to label data, you just provide clear prompts. Rapid prototyping, quick to experiment with different criteria and definitions of clippable. Outlines benefit. Outlines is fantastic here because it allows you to force the LLM's output into a structured format, example JSON. This is crucial for integrating LLM outputs into your scoring system. Example, confidence scores for different categories, extracted keywords, a summary, etc. Cons. Cost. API calls can be more expensive than running local smaller models. Latency. They can be slower, especially for processing many chunks, and determinism. While outlines helps with structure, the qualitative output can still vary slightly. All right. Hybrid strategy recommendation. Okay, wait. I'll look into this later on. For now, I want to look at the I need to describe the problem to Gemini and see what Gemini suggests. Okay, this is a great plan, and I'm most definitely going to be looking into a bunch of the stuff you have mentioned. I do have another doubt. While I can identify various topics throughout the chunks of the transcript, I also need a way to make sure that I'm clipping, or well, make sure that that entire discussion gets clipped, meaning I would need to make, I would need to know where the topic starts and where it ends, all in one contiguous array of chunks. I wouldn't want some chunks being at around the 10-minute mark and some other chunks of a similar topic being at around the 45-minute mark, but then the system tries to group them into one clip, and then the clip doesn't make sense. You get what I'm saying? Okay, you've hit on a critical point that's often overlooked: coherence and contiguity. Contiguity? Contiguity. Contiguity. That's a word. I've never used that word before. I've heard of I've heard of continuity. Well, okay, contiguous, contiguity. Okay. Coherence and contiguity of discussion. You're absolutely right. Grouping chunks from vastly different parts of the VOD, even if they share keywords, would result in a nonsensical clip. The goal is to capture a discussion unit or an event, not just a topic in isolation. The problem is primarily addressed by a technique called topic segmentation or boundary detection. Instead of identifying what a chunk is about, we also need to identify where the discussion about the topic starts and ends. Here's how we can integrate this into the plan. Integrating topic segmentation. Before you apply your detailed LLM analysis for scoring or as part of that analysis, you need an intermediate step to delineate these discussion boundaries. Semantic similarity for boundary detection. I think semantic similarity is part of sentence transformers. Okay, how it works, you can measure the semantic similarity between adjacent chunks or small groups of adjacent chunks. When the similarity drops significantly, it indicates a likely topic shift or change in the discussion. Process, get embeddings for each 60-second chunk using a sentence transformer model. Yep, okay. Using a sentence transformer model, which is much faster and cheaper than a full LLM for just embeddings. Calculate the cosine similarity between the embedding of chunk n and chunk n plus 1. Okay, so chunk 5 and chunk 6. Look for dips in similarity scores. A sharp drop means a certain threshold suggests, no, a sharp drop below a certain threshold suggests a segment boundary. Sorry, zoned out. Okay. Suggests a segment boundary. Benefit, this is a computationally efficient way to find potential. You know what? I might be able to do this locally as well then. If it is not that heavy, then I might not need to run this on, like, because certain things I could try doing, because there's a whole bunch of NLP related stuff that I'm going to have to do, that I'm going to have to study first, right? I have to learn how to do various things, how to extract various bits of information from the text. If the NLP models end up being light enough that I can run them locally, then I think I'll run them locally. Because then we'll also be able to do it on stream and see the results. That should be interesting. Give me a second here. Okay, sorry, zoned out. Where was I? Yeah. So one is semantic similarity, then LLM-based boundary detection, more robust. Leverage the LLM's understanding of context and discourse structure to explicitly identify topic boundaries. Feed the LLM a sequence of, say, 5 to 10 contiguous chunks at a time. Prompt the LLM to identify if a significant topic change occurred within that sequence, or if the current chunk marks the end of a prior discussion. Okay, crucially, use outlines here. You could ask the LLM to you could ask the LLM to return a JSON object indicating so and so. This might be done by prompting the LLM for each individual chunk, asking if it represents a topic shift from the previous chunk. Or I could just feed it like an entire dictionary of the timestamps and then have it return a list of dictionaries. That could work as well because the LLM has a big enough context window for at least that much. Okay, keyword slash entity occurrence. How it works: track the presence and absence of prom words. Track the presence and absence of prominent keywords and named entities. A sudden change in the dominant keywords, example, shifting from Python Django database to JavaScript React state management, can signal a topic boundary. Process: extract keywords slash entities per chunk. Analyze the overlap between adjacent chunks. Low overlap implies a shift. Okay. All right. Okay. So we've got some good progress here. Give me a second. Yeah, we've made some good progress here. Uh, Now I'm gonna look for someone to raid. Um, there is someone here who's, I'm not sure what this person is doing. Let me check. Let me see. Yeah, I don't know what this person is doing. Okay. But we're gonna go check out this person's stream. Um, yeah. There, wait, am I able to set up the raid? Yes, I am. Okay, that's gonna be it for today's stream. Um, yeah, dude, we made some good progress today. Hell yeah. We made hella progress today. I think I'll finish working on the windowing, the sliding window mechanism, time-based sliding window mechanism, and hopefully before tomorrow's stream, the mechanism should be done. It should be ready. And further from that point, all we have to do is start looking into NLP related stuff. As in start looking into NLP techniques, NLP tasks that we can perform on the on the chunks, and let's see what interesting information we are able to come up with. But yeah, dude, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.